Okay, and here's question 5 from one of your circular motion worksheets on banked and unbanked curves. We got a banked racetrack. The smallest circular path on which cars can move has a radius of 112. It's down there in the bottom. Largest is 165, and the height of the outer wall is 18 meters. Find the smallest and largest speeds at which the cars can move on this track without relying on friction. And so the formula we use is fairly simple. It's speed equals RG tan theta if we have banked curves. That's square rooted. One thing we're missing is that theta. If we can find the angle that the bankment is, then we're done. We have the radius for each one. We calculate it twice using 9.81 as our gravitational acceleration. So what we need to figure out is that angle right there. Well, nice for us that it's a right triangle with an opposite side of 18 and an adjacent side of 165 minus 112. So that might be the first thing you didn't notice we could do, when in fact we can, is the bottom of that triangle, there to there, can be figured out by doing 165, just by looking at the geometry, minus 112 for 53. So now I can figure out the tangent of that angle. The tangent of the angle is opposite over adjacent, which is 18 over 53. And that equals 0.3396. I'll keep 4 decimal places. And remember, the tangent of the angle is what actually goes in the formula, so I don't have to find what the angle is and then take the tangent of it again. It's a little bit redundant. Save yourself some work if you kind of look ahead and see what the equation is. All right. So we are ready to kind of calculate this through. So the smallest speed would come from the smallest radius. So that's V equals RG tan theta. Write it out again. Square rooted. So that's equal R 112. G 9.81. Tan theta 0.3396. Don't forget, all square rooted. Okay. So let's work the inside there first. 112 times 9.81 times 0.3396, which gives 373. Square root that. So the smallest speed to safely negotiate that embankment without relying on friction is V equal to 19.3. So if you're down at the bottom there, you got the smaller radius, you're going to have to slow down to about 19.3 meters per second, or else you're just going to kind of start flying off, or depending on friction, you might be all right. Then we do largest. Yes, largest. B equals, I guess the bigger R, I'll just go straight to the math, 165, 9.81, and times your tangent of your angle, 0.3396. That didn't change. Okay, you might be higher up the hill, but the angle made from the horizontal is the same. All right, so that works out to be 165 times 9.81 times 0.3396. So that V is 550 approximately inside the square root sign. So that largest possible speed, which would happen if you're up in the top of the bank because you're going through the biggest radius, it works out to be about 23.4 meters per second. So if you're up high, you can go a little faster. But if you're up high, you're going to have more track to go through. So 6 of one, half dozen the other.